Good afternoon. All right, we are going to just do a couple of normal distribution questions. I'm going to do one, and then I'm going to make a second video for the other one. But this one is one we did in class, but I just want to have it up there so you can reference it back. So here's the question. It says a company makes yogurts. Containers of yogurt, the volume of the yogurt is normally distributed as a mean of 260 and a standard deviation of 6. And it says a container which contains less than 250 milliliters of yogurt is underfilled. A container is chosen at random. Find the probability that it's underfilled. So I'm not going to write this part down. I'm just going to go to my calculator. I'm going to actually get out of this, go to my scratch pad, if it lets me. Hopefully it will. And then I'm going to go to Menu, Statistics, Distributions, and I'm going to do a normal CDF. The lower bound is going to be negative infinity. The upper bound is going to be 250. I want to know whether it's less than 250. My mean is 260, and my standard deviation is 6. And I just hit OK, and it gives me my answer. So my answer is 0.04779. So that's part A. Part B says the company decides that the probability of a container being underfilled should be reduced to 0.02. It decreases the standard deviation to sigma and leaves the mean unchanged. So find sigma. So here's what we're going to do. The first thing we're going to do is we're going to write down our information. Okay, so we know that the probability that x is less than 250 is going to be 0.02. We know our mean remains unchanged, so our mean is 260. This is part B. And we know that we're looking for sigma. Okay, so we have an x value, we have a mu value, we need a z value, and we're going to find z by doing the inverse normal of 0.02. All right, so we're going to take our calculator, we're going to go to Menu, we're going to go to Statistics, Distributions, Inverse Normal, and 0.02. We're going to leave the mean at 0 and 1 because we're finding a z value, and we hit OK. Oh, I thought it would put it in there. Should have. Distributions, inverse normal, 0.02. Okay, there we go. So we get a z value. It's negative 2.05375. So negative 2.05375. Okay, and then we use our little conversion here between z and x. So if we rearrange this for sigma, because that's what we're trying to find, we're going to get x minus mu divided by z. So that is going to give me 250 is my x value, 260 is my mu value, and my z value I just found was negative 2.05375. So that gives me 2.00 if you divide, I believe. And back to the question. It says, sorry, that's not right. I'm thinking the wrong thing. I thought that was a question where I was supposed to prove that it equals 2, so I didn't actually do the calculation. It actually, if I remember correctly now that I'm thinking of the right thing, is 4.88. Okay, so that's our mu value. I was thinking of the other question. So now it says the company changes to the new standard deviation and leaves the mean unchanged. And a container is chosen at random for inspection. It passes inspection if the volume of yogurt is between 250 and 271. So it says find the probability that it passes inspection. So we're not going to, again, write anything down here. We're just going to go, we're going to do a normal CDF. Our lower bound is going to be 250 because we want it to pass inspection, so it has to be at least 250, and it can't be any more than 271. It tells us that we're going to keep our mean the same, 260, and our standard deviation has changed to the new standard deviation, which is 4.88. And we get our answer. So our answer is 0.967683. Okay. Then I go back to the question. That's part C1. Part C2 says, given that the container is not underfilled, find the probability that it passes inspection. So what we're going to do is we're going to go, this is C part 2. We're going to say, okay, we want the probability of A given B. So that is the probability of A and B divided by the probability of B. So then we just have to figure, okay, what's A and B? So A is, you look at the question, it says, what's the probability that the container passes inspection? So if it passes inspection, we'll say A is passes, and B is not underfilled. Oh, whoa. So if it's not underfilled, okay, because again, if you go back to your question, that's what it says, right? Given the container is not underfilled. So that B is going to go right here. And A and B is that it passes inspection and it's not underfilled. So if it passes inspection and is not underfilled, it first of all can't be underfilled. So it has to be greater than 250. And in order to pass inspection, it has to then be less than 271, because if it goes any higher than that, it will not pass inspection. Then the probability is not underfilled is just the probability that X is greater than 250. So we actually just found this probability on our calculator, right? We just found it right here. So 0.967683, because that's the probability between 250 and 271. So 0.967683. 967,683. Is that right? Or did I? Yeah. And then I'm going to divide that by the probability that X is greater than 250. If we go back here, we know the probability that X is less than 250 was 0.02. All right. So what does that mean the probability that X is greater than 250 is? Well, it's just 0.98. Okay, and if I divide those, so I go here and I take this number and I divide it by 0.98, it gives me 0.987. So I'm going to put that as my answer. Okay, and then finally we're going to go back to the question, and it says a sample of 50 containers is chosen at random. So now we have switched from normal distribution to binomial distribution, where we have 50 trials. It's to find the probability that 48 or more of the containers pass inspection. So again, we go back here, we'll add into part D. Now we have the normal distribution of 50 trials. Our probability of success is the probability that it passes inspection, which is our 0.967683, right? It's the number we just took here. All right, and we want the probability that X is greater than or equal to 48. So we're going to go to our calculator. We're going to do a binomial CDF. So we're going to go to statistics, distributions, and we're going to go down to binomial CDF. Our number of trials is 50. Our probability of success is 0.967683. Our lower bound is 48, and our upper bound is 50. We hit OK, and we get our answer, 0.780. And that is the answer to this one. And we're done.